Atomstack P9 M40 portable laser. Got one right here. This has been provided by Atomstack for me to review. This is a pre-release review. This is not out to the public yet as I'm shooting this video, but there will be links in the description once it does become available on where you can get it. We're going to unbox this. We're going to put it together. We're going to do a little testing. Coming up. I'm Roger, welcome to the shop, and as I mentioned at the beginning here, this was provided to me by Atomstack. They're not paying me to do this, so any opinions I have and anything we find here will not be edited out. It will all be as it is, if it's good, if it's bad, if it's ugly. So we're going to find out. This is a brand new model. It's called the P9 M40. I have a few specs here, and like I said, this is pre-release, so and some of this is not exactly translated perfectly, I don't think. That'll probably get perfected. Say the print size, recommended print size is 220 by 250 millimeter, but the working area is 410 by 400 millimeter. So we'll find that out here shortly. Laser input power is 40 watts, output power is 5.5 watts. Fixed focus. Of course, it'll work with laser Gerbil and Lightburn and etc. We'll get to that as a fixed focus laser, as I mentioned. I know it has something, I know it's 0.08 by 0.08 millimeter focal dot. That's pretty good, that's pretty fine. And it says here that it can directly engrave mirrors, stainless steel, metal, ceramics, 15 millimeter black acrylic, cut 15 millimeter wood. We're going to find out. Though I don't normally do much cutting. And it says it can achieve the effect of a 100 watt CO2 laser. I don't have a CO2 laser to compare it to. I do have quite a few diode lasers. So we'll get this unboxed here and we'll get her put together. I did cut the first box open to find out that there's another box inside. So we got a box in a box. So let's see what we got here. Yeah, like you see, I got it upside down. Nice little carry case there. Yeah, we'll open this up, see what we got. You ever have one of them times when you really need to be smarter than the box? Yeah, there is a cutting mat that comes with it. I also have the Atomstack A5 Pro, which also came with a cutting mat. Some foam here. The user manual, and this is multiple languages, yes. English, German, and French. I will only be using the English part because I don't do German and French. We got a little bag of parts here. USB cable. Looks just like an HDMI cable, but I'm sure it's the cable for the remote, which is right. Well, it's in here somewhere. Power cord. Little snack pack here. Ah, do not eat, darn it. Power supply. And some other little parts and pieces here. To figure out how this foam is in here exactly. There's the laser head itself. This is the little remote control. What's going to be nice about this one is you do not have to have it connected to a computer to operate it. You could, for example, in Lightburn, generate your G-code, save it to a micro SD card, plug it into this, and go. Yeah, maybe it doesn't plug into this. Must plug into the... Oh, we'll find out. It plugs in somewhere. Riser blocks. We'll say this is well packed. Here's the brains of the operation. I'll make sure there's nothing else in here. Okay, you can see all the little parts and pieces that come with it. For the assembly parts, you get a couple of alien wrenches, a combination open-end wrench there, some non-woven fabric, some plywood blanks to play with, some acrylic blanks to play with. I assume this is going to be the focusing plate. You have a micro SD card with a card reader there. And these are labeled step 2, step 4, 5, step 3. Everything's labeled here, so let's get going, put this thing together. Okay, our first step here is to push the X-axis component along the dotted line into the guide rail. That would be right here. And now you need to check the eccentric nut, and this is actually set pretty close. If you don't know what an eccentric nut is, there is a nut here. I've got to find it. These nuts right here are what they call eccentric. They're not perfectly square or round. So as you turn this, it will tighten or loosen the wheels. Yeah, it's a little bit loose there. What you don't want to have is wobble. So you'll turn this one way or the other until there is no slop. You're actually very close. You want the wheels all turning smoothly. You don't want anything hanging, and you want this to glide easily, but you don't want any up and down play. So there's that step. Next we'll be putting on the brackets. This is really pretty simple. There's not a whole lot to this at all. Business end goes over here on this side with the feet facing out here. And this would be the step 2 screws. And they do give you a Allen wrench to go with this, but I prefer these. It's 3 M&Ms if you're keeping score. It's a little bit easier for me to operate with. And there are threads in the end. Of course, you don't want to tighten one, you got the other one in there because you need to do a little bit of alignment. And of course, as you do this, you will want to get the square right here. You don't want it to be off like this or like this. You want it to be square. You'll do the same thing on the opposite end here. There again, make sure you are square before you tighten your screws up. And I'll get the parts together here for step 3. Okay, this step we'll be doing the timing belt. On the end opposite the stepper motor over here, there is a hole machined into the extrusion, and you will have these parts. It goes together like this. You'll have the screw. The bearing has a flange on it. Hopefully you can see that there. It'll end up mounting to the screw like this. So the screw will come through there, and they call this what I call a spacer, what people around here would call a spacer. They call it a cylindrical pad. That would go on next. Then that threads into that hole right there. And you want to check that and make sure your bearings turn free, and they do. Next, in the timing belt, you want to get that straightened out. And notice on the sprocket of the stepper motor there are teeth on that sprocket. Well, I can get this up there where you can see that. The teeth on the belt will obviously face the teeth on the sprocket. So we'll need to get that threaded around through there. It'll go around your pulley out there. There's some little brackets right here in the center where these just clip into. Okay, to set the belt tension, you should be able to get your other clip into the bracket there. There are a couple of screws down here that can be loosened up. So you can slide that, you don't have to take them out, just loosen them up. So you'll be able to slide that stepper motor over to get that clipped into the bracket. And you can pull the stepper motor back a little bit. You want good tension on there, but you don't want it so tight that things are hard to move. So don't try to stretch it. You want good motion like this. And that belt's a little twisted, but it's cold in here, and this was cold outside, so it'll straighten out over time here. Okay, next step here is the laser head on the foot pads. And we're going to do the foot pads since I already have this upside down. Little foam pads here, and they just simply go on the frame and fold over the frame. We'll keep this thing from sliding around. I may come up with some 3D printed brackets to mount this to a board, but otherwise it's meant to be portable, so you can take it from place to place and place it on things. So this part here isn't too tough. Okay, get this thing rolled over here, put the laser head on it. We'll say this is nice and light. Okay, the mounting of this is identical to my Atomstack A5. This just simply slides down into this bracket right here. Then there's a knob right here in the front you tighten up. And obviously you want the end with a little circuit board and the wiring to be up. So now we got a few cords to plug in. You'll see down right by the motherboard and the controller here is a little blue plug. That will plug into the stepper motor. It is keyed, it only goes in one way. Don't force it. If you bend those pins, you'll have a dickens of a time getting them straightened out, be able to plug anything in there. It only goes in one way, and then it goes in fairly easily. Of course, you want to make sure it's in there all the way. Then on the other end here, you will have another stepper motor plug like so. Get this turned around. I turned this upside down so you can see this better. There's a red plug and a white plug. The white plug plugs into the circuit board that's underneath. And there again, that's keyed. It only goes in one way. And don't force it. The other plug is red. It plugs into the stepper motor, and again is keyed. Okay, so we're all plugged in there. Now you'll have your laser cable, which is right here. Both ends are the same. This plugs into this end of the board. And again, it's keyed. And now we'll turn this back over. Get my wires untwisted here. And this plugs into the top of the laser, and it again is keyed. It only goes in one way. And except for plugging in the power supply, by golly, assembly is complete. Not much to this one. Okay, I don't want my cords here because it's very cool in here, and this thing had been outside, and it's cold out there, so there's a little protective thing here on your remote screen. And you have this cable here with the coil cord. Looks just like an HDMI cable. Plugs in there, and then right on the side of your laser control box is another one. And that's held on by a magnet. Okay, I've got my power cord hooked up here, and this is emergency stop. If you would hit that, you'll need to rotate it like this so they get it to pop up. It will not, you can't just pull it up and Once you hit it, it stops everything. Of course, the power plug's in right there. We need to take this little TF card here, or micro SD card as I call it. Little slot there for it right on top. Put that in there. I have this sitting on a piece of plywood now in case I do something stupid. I don't want to set this cardboard on fire that's on top of my table saw here. Okay, we have our little display here. And we turn the power on. And the display should come up. And it's upside down. And this is going to be impossible for you to see on the camera. I can see that, but the settings here, touch tones. That's loud, about. Machine size, 220 by 250. 2mm carved butterfly or a cut dog. We'll do the carved butterfly, but first we need to set the focus. To do that, we have this piece of acrylic right here, and that is set underneath the laser head. So it just drops down on it. You tighten that back up. Remove that piece. I don't know how square we're going to be here because I don't have anything to square off of this really, but this is just for a test. Incidentally, this does not come with laser safety glasses. You really should get them. This is well shielded, I see here, but especially if you're cutting something or engraving something like, well, you won't be cutting glass, but if you are engraving glass, the reflection of that can be very, very hazardous. So it's something to keep in mind. So we'll do the file that came with it, the butterfly, and first I want to frame it. It's loading the file. Thinking I need to home this first. Take it home. Okay, we are home. This does have limit switches. I have some other lasers that do not, and that can be a real pain. So we want to position this. I need to set some belt tension here. The belt is not tight enough on the y-axis. Okay, to tighten the belt, there's two screws on the bottom at the end of the y-axis bar. You just loosen those screws up, and that pulls out. You can tighten the tension up on your y-axis belt. This one was just slipping around the pulley. It wasn't anywhere near tight. So that I didn't see anything in there about checking that. Maybe I overlooked it, but definitely something you need to check. All right, we'll get this set back down here again. Turn this back on. And we'll go to carve. The 2mm carved butterfly. We're going to home it. Homing succeeded. Now I need to move this. Since I have this thing setting sideways, it's just the opposite of what I think it's going to be. And I'll check my focus again since I fiddled with it. And yeah, it's a good thing to check that. Let's get position here again. I want to get this more over out in the middle of the board. Then I'll set my position. Touchpad does work quite well. Okay, now we'll set position. Now we'll frame it. And we'll start. And we just want to do one pass here. I don't know what exactly the settings are. This is a piece of MDF here. So we'll let that run. Okay, you can also adjust power and speed from the keypad here. Hopefully you can see the graphics there. By increments of 1%, 10%, or 20%, you can increase or decrease both power and speed. You could pause this and you can stop it right from this touchpad. Right now we're at 60% complete. Okay, and there we have it. File print done. Say yes. So we get rigged up here for the little cut test, the little sample they give. Right here is what it just burned, a little test file that comes on the micro SD card. I'm going to use one of the little pieces of 1/8 inch plywood that they gave with this, and we'll set the focus here. I have it setting on one of my honeycomb grids here because I don't want to scorch this plywood underneath. And then we'll need to get a position set. So we'll go here to carve. 2mm plywood, cut dog. So we want to set position. I want to frame this. Make sure I'm going to be on the wood. It looks like I need to turn my little piece of wood the other direction. This here will move it to center. Okay, now we'll frame this. It does put out a little beam of light so you can see through the shield there. Incidentally, while this was cutting, I had my laser goggles on and I could not see the beam. I had to take my goggles off to be able to look through the shield and see the beam, because that really shields it. That must be why they don't send you the glasses with it, but there again, you want, if you've got glass or anything reflective, you need to have the safety glasses on. Okay, let's start. And I assume this will cut it in one pass, so we'll say yes. And my little piece of wood isn't sitting there very straight, but this will work. It appears to be cutting through because I can see the reflection off the bottom of the pan. Okay, there we have it. No scorching in the back either, to speak of. This little dog there, I guess depends which way you want to look at him. I need to try this once I get it in the Lightburn and be able to check my settings a little closer. Okay, to get this set up in Lightburn, I have Lightburn open. I was running this laptop on another laser. I just went over and grabbed it. So turn the laser back on here. So go to my tab, laser tab here, and I'm got to click on devices. Bring that up. I'll click on find my laser. There it is. I'll show you what I did here in just a minute to make that work. And we're going to call this the Atomstack P9 M40. And mine's in inches, but I can always mess with that later. And it homes at the front left corner. Click finish, and okay. All right, what I did was over here, it was on COM5 before. I had to put it on choose. And then I went to devices and find my laser. Now I just need to drop down here, the right one. And put a file in there. Yeah, let's do something I just did. We'll do this tile here. So I just need to get a tile and get things centered. Okay, I've got my focus set here. I've got this in there relatively square. I'm used to working off a grid. I don't have a grid here yet. So I squared this up the best I can, so I guess what we need to do next here is to frame that. And we appear to be in bounds. I'm going to use the same setting here as I was using on another 5-watt laser, which is 1000 millimeters per minute at 100% power. This is a ceramic tile. It does take quite a bit to engrave these. We'll start this and see how it does. The engrave time on this is 26 minutes, so I will say I'm not going to run this video here for 26 minutes, but we'll come back to it after it gets progressed a ways. Okay, something I've noticed here running at 100% power, even though there is a shield on this right here, if you're going to look at that, you definitely need to have the goggles on, or at least some safety glasses. These are the correct color for a blue laser, or the orange. But if you're going to be looking directly down at that while it's operating and staring at it very long, you need these. Protect your eyes. Okay, the burn's complete, so we'll take this off. I'll take it over and strip the paint off of it. We'll see how it looks, compare it to one of the other ones. Okay, so what's the difference here? The one on the bottom was done right here on this new Atomstack. The one on top was done with the A5 Pro. The detail on this one here, the new P9, is much more fine, a lot finer detail. However, the A5 Pro was darker. Now, obviously, I need to do a burn test on this. You need to do a burn test on any laser. They're all different. They're all going to have their own little different power settings, and depending on how they're focused and everything. But I thought the best comparison would be between the Atomstack A5 and this P9. As far as the depth of engraving, they're both about the same. As I said, this one here is a little bit darker. This one has a lot finer detail. Okay, next test I'm going to do here is 3,000 millimeters per minute. It's just a very, very quick line drawing. I want to see if this laser is going to walk around on this board. I know all of my other ones do when you get up to 3,000 millimeters per minute, and they just start walking around. But I'm going to see what this does, especially since it's so light. So this is a little simple cartoon face and a piece of cedar. And we'll frame this here quick. I'm not making it very big. Just want to see how well this is going to go. And we'll start it here. So that will come out pretty good. I'm going to scoot this over. We're going to speed it up even more. Okay, going to double the speed here. Frame this and go. Just starting to walk a little bit. Okay, going to do a test fill on just a little cartoon face on this piece of cedar at 6,000 millimeters per minute. See how much this shakes around. We'll frame this. Okay, we're good. I'm starting from center. Okay, so here's the results of that little test. It's a good engrave. A little bit of scorching on there. Of course, this does not have air assist. But something I did notice was that the fan that cools the laser does blow down through and it evacuates the smoke pretty well. I think air assist on this would clear up that scorching a little better. I've added it to my other ones and it's made a big difference. And my next little test here is a cut test. Now that I'm in Lightburn and I can see more what's going on. This piece of 3mm plywood, I'm going to cut out a sprocket. So we'll frame this. And we'll see how this does. This particular cut has a lot of fine detail in it because there's a lot of very, very small holes in the center part of the sprocket hub. Doing this in 2 passes, 500 millimeters per minute, 70% power. Okay, let's see what we got here. I don't think that cut through quite all the way. Oh, yes it did. And it's extremely precise. So I got a couple little pieces there I got to poke out. But this is did a very, very good job. Very little scorching. Very precise. So, yeah, I'm really impressed with that. By the way, these blocks that come with the laser, that's actually for assembly. Little jack stands, you can hold it up to assemble it. I chose not to use them for that, but you certainly could. And then I did play around a little bit to see how the laser would sit on this. If you use all 4 of these, you could use this to raise it up if you were to use a rotary attachment, which would attach to the X or the Y-axis on it. It's I have not tried that, but it is something you could do. But these are actually for assembly. So to prevent this video from getting to be too excessively long, I'm going to keep this at the level of the unboxing, the assembly, the software setup, and some preliminary tests. I have done other tests. There's a burn test on cedar. I had to stop it because it was starting to engrave too deep. This was a little more powerful than I expected. I did do a cut test, and I have done a burn test on ceramic tile, which is what's engraving right now. I wanted to do some more tests yet and actually make a whole testing video, but we got a rather large order and I'll show you what it's for here in a minute. And I've also done an engraving test on slate coasters, so I've got some benchmarks to work with there. I'll be also doing some stainless steel and some more cutting coming up here shortly. So what am I making here with this ceramic tile thing? It is this graphic right here, which after the paint is cleaned off looks like this. And I have an order for quite a few of them and I need to get them all burned. And in fact, I have 4 lasers running right now, all doing the same thing. Okay, what kind of modifications have I made on this laser? If you've watched some of my other laser videos, you know I'm always tinkering and making them better or whatever. You know, adding air assists and drag chains and that type of thing. So what have I done on this to modify it? Nothing. So far I have not found a reason to. The cables are not getting in the way. They are well managed here. It's very chilly in here right now, hence the sweatshirt. So cables are a little stiff, but have not had any problems with that. I did make some mounting feet, as you can see here on the space-board. And well, I'll get into details with that when I get into the whole testing video. That keeps this from shifting. I did burn a grid, a layout grid, so I could repeatedly make the same part. And right now I'm running off a computer, but I have ran it off the micro SD card. Just loaded the G code on a card from Lightburn, put it in there, set my position and everything, hit the button, let it go. This little keypad here works great for that. So that's, you don't have to have another Lightburn license, I guess. And I've got 6 of them now, so I didn't really need another one. This saves me from having to attach another computer too. So That's a really good point about this. As far as portability, it's very light. You can take this from place to place. It's very easy to move, very easy to set up. So why you need a portable laser? Well, maybe you want to engrave something on a door. So you would take the door off the hinges, you lay it on sawhorses, get your layout, get your laser set down on it, lay out where you want your graphic, do a frame, burn your graphic. Easy to transport, pick it up, take it away, put the door back up. That's just a thought. So just a preliminary thing about cutting performance, how well does it do? As you saw earlier in the video, I had a little bit of trouble getting through the sample piece of plywood. It didn't quite burn through on the pass I expected it to. Fiddling with the settings a little bit. Of course, I had no benchmark to go off of. I have since run a burn test, a cut test. I know where my best cutting is. This 3mm plywood. It's one of my little cogs with the fine detailed center spokes, and that is cut at 200 millimeters per minute at 60% power, and it does an excellent job. It's very little scorching. There is air that blows down through the laser, which helps evacuate smoke and helps keep the lens clean. It's not the same as an air assist, which would actually blow directly down into the cut. But this works very well. It's not something I'm going to be used for cutting. On a large scale, I have other things I can use to cut with. I have more powerful lasers and bigger ones if I decide to do cutting, and I don't do that much. They're making these little gears for someone. Okay, engraving on wood. I did a burn test here, and as I mentioned, I had to stop it because it was actually starting to engrave too deep as I went into the higher powers and slower speed, so I stopped that. I do quite a few laser engraved signs, and we use cedar. And here's one of them right here that was done on this laser, but it just barely fit. This is something I should have been actually doing on one of my other lasers. I had to do it in two parts, to do the graphic on top and then the lettering on the bottom, because the bed wasn't big enough to accept this entire length. But it did an excellent job. This does have a finish on it now. It didn't come out that shiny, but nice black color, nice uniform engraving, and very, very detailed and clear. So what do I think of this laser? At first impressions, I'm impressed. I'm especially impressed on how fine of a line it engraves. The speed on it is excellent. It's very stable. I don't have any problems with wheels wobbling. I do have my eccentric nuts set good, but I don't have any problems like I've had with one other one before where the wheels actually had grit in them from the factory. So there have been no little idiosyncrasies with this or anything at all. I will be doing a follow-up video after I do some more runs with this and testing, and I'll be demonstrating it on some more materials besides just wood, cardboard, and tile, and I guess I didn't even do the slate one yet. But I will also be doing another one of these burn tests on tile, because since I'm going to be running so many tiles through this, we'll find out how the life of that laser head is going to be. I had one here previously that degraded horribly after about 20 hours of use to the point where it wouldn't even engrave tile anymore. So we'll see how this one does. I also have an Atomstack A5 Pro, and I have not had any degradation with that laser head at all. So I'm assuming this will be on par with that. So there's my first thoughts on this Atomstack P9 M40 laser. How well it works, how easy it was to assemble, what all you get with it. As I said, there'll be another video to follow this up. So if you got anything out of this, appreciate getting a thumbs up. Always helps the channel. And of course, we're always looking for subscribers, but everybody says that. You got a YouTube channel, you want subscribers, so please subscribe. Otherwise, I'm Roger in the shop. Atomstack P9 M40 laser. Thanks for watching. See you in the next one.